Welcome back to our Prelims Masterclass, wherein we are covering or revising your current affairs for last 1.5 years. So in this, we had started space technology for the science and technology section, right? And today I'm going to continue that space technology section and we'll complete that section today. Now before we start, a notification from Naranaya's Academy, our 1-year and 2-year courses are active. If you want to take admissions, you can go for all the details regarding these two courses and you can click on the link provided in the description box. Okay? Now moving ahead. Here we are dealing with space and technology section, which I said that is one of the most important sections when it comes to science and technology part, especially the questions will be more or less from the current affairs segment. So 11 questions in last 10 years which shows its importance, right? And some section we have already covered, some part of it we have already covered in the last lecture, that is lecture number 4. Now today we are going to deal with few more topics which are very relevant from exams perspective. Now before I start with one of that article, look at this previous year question. This was asked in the year 2018 with reference to Indian Regional Navigation Satellite System, that is IRNSS. Consider the following statement. Now the topic is navigation satellite. Navigation is an important aspect when it comes to satellites. And here it is specifically talking about a system which is relevant for India. It's India's GPS, you can call it. Okay. Now if you look at this previous year question, you will see the factual statements are very clearly given. 3 satellites in geostationary, 4 satellites in geosynchronous orbit, then 5,500 square kilometer area beyond its border when it comes to IRNSS. Is it covering this much area for India? These are very factual statements. This aspect is a technical aspect and again a factual part. So from this we can understand that this particular topic, the navigation satellite, this segment, it becomes very important and factual part we must be aware of. Okay. So if you look at this PYQ and look at this topic that I am going to cover right now, that is GNSS based tolling system. So here we are talking about global navigation satellite system, and on the basis of this global navigation satellite system we are bringing in a new tolling system. Okay, how we are doing it? See, earlier we had this toll plaza where toll was being collected. So if you are taking your car from one place to the other, and if you are using a particular highway which is built by a private company or any company, now to provide you such services, such good quality services, some amount is being charged from you through this toll plaza, right? But we observe many a times that on these toll plazas there is a long queue of vehicles. When there is a long queue, because of this, first of all, the time it consumes, that's a problem. Second, public do not like it, public will not find it very good for them. But main problem would be the emission. When you are letting these vehicles stay in the queue, that is leading to more vehicular emission, right? And that's not a good way to manage the traffic, manage the transportation system. Now government thought we'll bring something new. So they brought this FASTag system, right? At this moment most of you are aware of FASTag system. So FASTag, here they are using radio frequency. So there is a FASTag code or some chip is there on your car or vehicle, and whenever you reach to this toll plaza it will get scanned. Now here we have reduced this queue to some extent, because you don't need to wait there to make your payment and all, automatically payment is made for your toll, etc. But still now government is thinking about a new solution to solve these problems related to this congestions, queues and payment and etc. So now we are bringing in something called GNSS based tolling system. So now we are going to make use of navigation system by making use of satellites. Okay. So till now we have not made any use of satellites as such to solve this problem of tolling and all. Now we'll use satellites. How this will happen? First of all, understand this global navigation satellite system. Whenever we say navigation system or navigation satellite system, so we are trying to make use of satellites for navigation purpose. Navigation means it will try to find out your particular location, where you are located, how you are navigating, right? So to navigate you, this system is going to help you by providing you maps, by directing you to go at a particular location, etc. The best example would be your GPS to understand this global navigation satellite system. So it's a system which is developed by different countries. Let's say this GPS, it is developed by United States of America. So they have multiple satellites which they have sent already in the space. Through those satellites, they are getting images, information, and they are making those maps, and they are redirecting you, they are navigating you. Okay, this is one system from United States. Other system we have called GLONASS from Russia. Similar kind of system, or you can call it Russia's own GPS. Then we have Baidu system from China. China has also built its own navigation system. Now there is one thing you need to understand, why different countries are building their own navigation system when we already have GPS. One of the reason becomes the national security. Let's say we talk about the Kargil war. At that particular moment, India asked for some maps, some details, some navigation details from United States or from this GPS part, so that we could get the details of some terrorists, or let's say some people from Pakistan side. At that moment, if USA is saying that we can't provide you those details, that shows that we are so much dependent on the USA for such information. If we have our own system, we don't need to depend on them, right? That's the reason we see many countries have been developing their own navigation system. And obviously it's better to rely on self than relying on other countries. Now, China has Baidu, European Union has Galileo, okay, Galileo system. Then this QZSS by Japan, and lastly we have India's IRNSS. Now it's the same one which has been asked in the previous year question, which I have shown you over here. Indian Regional Navigation Satellite System, that is IRNSS. Okay, I'll discuss this part in detail also, because we have one more article on this IRNSS. Okay, now see, you should remember these names, because a very easy question can also be there showing the name of this particular what we call this navigation system with the particular country. Okay. Now these are all systems, if we put it together, we call all these systems as global navigation satellite systems, which are providing positioning, navigation and timing services. What's your position, how you can navigate, what's the time, all that thing will be provided to you by this system. Okay. Now we are saying for the toll purpose, for the tolling system, we will make use of this GNSS. The GPS, IRNSS, will use all this for this tolling purpose. So how this will happen? Now we want to discard FASTag. Instead of FASTag, we will try to locate vehicles using these satellites. Okay, how this will happen in a technical term, if I have to say, you can say that we have this satellite which is going to observe the vehicle. How it will observe? In the vehicle, you will have a chip or a device. The name of that device is OBU. Okay, it's called on-board unit. It's called on-board unit. This is a device which will be there in this vehicle. It will be installed in the vehicle, and this is going to record the distance and timestamp. Now there will be some machinery which is present on those toll nakas or toll plazas. So they will act, those toll plazas will act as stationary enforcement gantries. Now whenever a vehicle is passing, then all that data related to its distance will be calculated using this satellite data, and which is being cached over here. So what will happen, you see, the exact distance a vehicle is traveling will be calculated over here. See the difference. Earlier when we were using FASTag or even the traditional way, if you cross a toll plaza, then you were paying for using that highway. but if you don't cross it, you don't pay it. Let's say you want to cross just 1 kilometer and still you are paying the toll plaza. Other vehicles who are crossing 50, 60, 70 kilometers, they are also paying the same amount. Now this is not a fair system. If I am using just 1 kilometer, why am I paying for 50 kilometers? So if you use this satellite based system, now how much distance this vehicle has travelled, this will be calculated using this satellite data. So you will have exact distance, and now you will have the billing system, a centralized toll system or billing system through which exact amount will be calculated. So you will be paying the amount which you deserve to pay, or the distance you have travelled, for that distance only you are going to pay this amount. Okay. Now you see, you don't need toll plazas as such. If you look at this, you don't need them in future. So in future when we implement it, you don't need to wait in those queues, because this data will be automatically calculated. Automatically the amount from your account will be deducted. So you don't need to wait at those toll plazas as such. So this is a very good system, we can say, for the transportation system in India. Okay, this is GNSS based tolling system. So one thing we are going to get as a benefit, barrier free tolling, no stops at any toll plaza, and that's why this congestion problem, this vehicular congestion, will be reduced in a very significant manner. Then distance based charging, that means exact you pay the amount you deserve to pay, and reduced leakages. Many a times when you have people involved, they do some leakages. Sometimes it's not possible for authorities to understand whether which vehicle has travelled to which place and all. So all these leakages will be reduced to a good extent, because satellite is observing you. You have the right data available, and that's why you will get the correct revenue which the government or the authority must get. Okay. So that's all about the first topic or first article, that is GNSS based tolling system. You can ask any, if you have any doubts, please ask if you have any doubts. No? Okay. Okay, now moving further then, next article. Next article is about CE20 cryogenic engine. So recently ISRO has completed the final ground test of this cryogenic engine. The name is CE20. Okay, and they are saying that for the Gaganyaan mission we can certainly make use of this cryogenic engine. They are saying that we can use this for this human space flight which we are planning through Gaganyaan. Now we need to know what is this cryogenic engine. If you remember, in the last lecture also I had discussed very briefly, not completely, but I had one term used in this launch vehicle part, where I said that we have PSLV, GSLV, and we have this GSLV Mark III, also known as LVM3 or Bahubali rocket. Now this GSLV Mark III, it has 3 stages. First stage is using solid fuel. Second stage is using liquid fuel. But the third stage is using cryogenic engine or cryogenic fuel. Okay, I did not discuss it in detail. Today I will discuss that part. What is this third stage called cryogenic stage? First of all, what do we mean by cryogenic? When we use this term cryo, cryo means very low temperature. Very low temperature. Now when you are using fuels at very low temperature, when the temperature of those fuels is very low, in that case we call that engine that we are using is a cryogenic engine. Now see, here what we do, we make use of liquefied gases like liquid hydrogen and liquid oxygen. you go to space. In the space there is no air, there is only vacuum. So even if you are trying to burn any fuel, you need some oxygen, right? So here we have oxygen or a kind of oxidizer to burn it, to ignite it. But the real fuel which will be burnt, we need that fuel also. So here we are making use of hydrogen. Now I am using a term called liquefied hydrogen and liquefied oxygen. At normal room temperature, oxygen and hydrogen, these are in gaseous state. They are gases, they are at gas. If you want to make them liquid, you have to cool them down. You have to reduce the temperature so much that after a point, these two gases will turn into liquids. Okay? So when you are using these fuels, that too they are being stored at very low temperature. Okay? And whenever we have to use it, we can convert them into the gaseous form. So this engine which is using these fuels at very low temperature, such engine is your cryogenic engine, and it's very difficult, very complex task to make such an engine. Normally the engine that we were using in PSLV or GSLV, the fuel is there, solid or liquid, normally you go and just burn it. But here you have to store it in the liquid form, which is a tough thing. At such a low temperature, it's a tough thing, right? Now just a short comparison with the traditional system or the conventional engines and these cryogenic engines. In the conventional engines you are using the fuels, normal fuels, liquid or solid. Here you are using only liquefied gases as fuels. Then what is the efficiency? As far as conventional engines were concerned, when we are taking those fuels, the efficiency was relatively low. The fuel used to burn, but not completely, little efficiency was relatively less, we can say. But here it is very high. Why it is high? Because when you liquefy these gases, they become dense. In the same volume, you are putting more gas by liquefying it. So because of this higher density, you see the efficiency is also higher, relatively higher. Then look at the environmental impact. When you take any other conventional liquid or solid fuel, somewhere you see some kind of emissions taking place, some harmful gases or harmful chemicals coming out. But here we are making use of hydrogen and oxygen. Hardly we see any emission as such. So these are relatively cleaner gases and cleaner fuels that we are using. But I said, as compared to this conventional engine, making or preparing this cryogenic engine is a very tough task because it's going to be very complex. That's the reason when you look at the cost angle, this conventional engine will have a very lower cost as compared to this one. This will be having very higher cost because it's a complex stuff to make this thing. Okay. Now when do we use cryogenic engine? Whenever we want to go for some advanced mission, where we want to go for very heavy lift missions, our payload is very having a very high weight. Normal PSLV or GSLV cannot carry it. So you need more energy, you need fuel which can give thrust in such a way that even this heavy payload can reach out to the space wherever we want it to go. That's the reason you see, if I have shown these launch vehicles to you, we are not using it in PSLV, we are using it in GSLV, but the advanced version of GSLV, that is Mark III. Here we are using this cryogenic engine more or less. Okay. Although we can make use of it in the main GSLV or the other GSLV versions too, but the core, because GSLV we are using when we have to go for a higher payload, that too in geosynchronous orbits. That's the reason here normally we don't think about cryogenic engine. In this category we think about it. Okay. Now come back to this CE-20 cryogenic engine, for which a green flag has been given by ISRO just recently. Now see, CE-20 engine, first of all it powers the cryogenic upper stage in the LVM3. So in LVM3, that is this GSLV Mark III, stage 1, stage 2. In the stage 3, we are going to use the CE-20 engine. Then it is developed by Liquid Propulsion Systems Center. This is ISRO's subsystem who has developed this particular engine, and it's among the most powerful upper stage cryogenic engine globally. That's an important fact. If you look at the cryogenic engines being developed throughout the world, now this is one of the most powerful one. So very good thing we can say. Now it is using something called gas generator cycle. Now this is a technical part we need to understand. When you are making use of these liquid hydrogen, liquid oxygen, etc., what you want to do is you want to generate some energy, and using that energy you want to give some thrust to these satellites or these launch vehicles, right? You want to send this vehicle, so you need some energy, some push is needed. Now here, first of all, you have to put this hydrogen and this oxygen into that tank or wherever you want to burn it. You have to put it over there, you have to push it over there. Now to push also you need some energy, right? So some kind of pump, just like water pump we have to push the water. Similar kind of pump is required over here, and for that pump to work you need some energy, right? So that's the reason what we do is some amount of this hydrogen and some amount of this oxygen, this fuel and oxidizer, some part of it, very small, very tiny part of it is put separately and it is used so that we can run this pump. Okay, that's what we call as gas generator cycle. We are using a small amount of propellant to power the pumps feeding the combustion chamber. So where the main combustion has to take place, to provide it with fuel and all, we are using these pumps, which we call as gas generator. Okay, and this is not something new actually. We are already using it in Ariane 5, Falcon 9, Long March 5, all these rockets, they are already using this kind of technology. So Indians also thought that we will also use that. Okay. So this is all about CE20 engine. Now, as far as its thrust is concerned, now this is a technical part, try to remember this. The thrust that this CE20 cryogenic engine is providing is 186.36, or you can remember 180, at least you can remember the range. So 186 kilonewton in vacuum, that is in space we are talking about. And we have already used this cryogenic engine in different missions. So there are 6 missions wherein we have successfully used it. The famous ones are Chandrayaan 2, Chandrayaan 3 and these OneWeb commercial missions. Okay. So this is all about CE20 cryogenic engine. Now if you have any doubt, please ask, or else we'll move ahead with the next article. So next article is about methane sat. Okay. Now see, similar kind of names are there in news many a times, and UPSC keeps on asking. Let's say in 2016 they asked about astrosat. Okay, obviously the factual details have been asked about that particular satellite. So similar kind of question can even be expected when it comes to methane sat, right? So let's see what is this satellite all about, methane sat. It is launched by Environmental Defense Fund, and it has conducted this project, or it has launched this project in collaboration with different agencies. So we have this Harvard University, Smithsonian Astrophysical Observatory and New Zealand Space Agency. Now here comes the role of New Zealand. We can say this is the first such project or first such satellite which is funded by the government of New Zealand. Okay. So all these agencies are involved in building this or launching this methane sat satellite. It's a satellite. Now what is this satellite all about? Obviously the name methane is here, so there is something related to methane, right? So the main objective of this satellite is, when it reaches to the space, what it will do is, it is going to observe or monitor this methane gas. Whatever methane gas is getting emitted from Earth, let's say from factories or let's say from agriculture, wherever, how much methane is getting emitted from which place, from which country, all that data will be provided by this methane satellite. Now, why New Zealand government, or why we are thinking about this methane gas as such? Because methane gas is quite important when we study about global warming. See, normally we blame carbon dioxide whenever we talk about global warming. We say that because of increased or excessive carbon dioxide, this global warming is taking place. But you see, it's not only carbon dioxide, but there are many other greenhouse gases because of which, because of their excessive amount in the atmosphere, the heat is getting trapped. What happens simply is heat, the sunlight which is coming, the heat energy which is coming, which is getting into the earth. Now, earth is going to reflect back this radiation, and this radiation will be trapped by some greenhouse gases, because of which the heating of the earth will take place, or the atmosphere will keep the earth warm. If these greenhouse gases, the number or their amount increases, then there will be more heating, and that is what is happening right now in the form of global warming. Now, the point is, specifically we are talking about methane, because if you compare the global warming potential global warming potential of carbon dioxide with that of methane, you see methane is 25 times more. Its global warming potential is 25 times more than that of carbon dioxide. So, it is trapping more heat than that of carbon dioxide. That is the reason we are concerned about methane. Okay? So, that is the reason even the New Zealand government has funded this particular project. Now, here this methane sat, it is going to circle earth 15 times daily, and what they are going to do is, all the data they are going to receive in real time, they are going to publish this data online, so that everyone can see this methane emission taking place everywhere. Now, look at the technological aspects. So, there are some sensors, so which are going to provide high resolution data. So, high resolution infrared sensors are there, they are going to detect the methane emission which is taking place. So, wherever methane gas is there, that will be detected by these sensors. Then we have spectrometer. Understand the difference. When you are using these infrared sensors, they are just sensing, they are just telling you that here we have this methane gas, they are identifying it, but they are not calculating the amount, the concentration of methane gas. This will be done by spectrometer. Spectrometer is famous for helping us know the concentration of anything. Here we are using it to calculate the concentration of methane. Okay? And this is very sensitive spectrometer, we can say. We can know the amount of methane as low as 3 parts per billion. So, even if very micro level emission is taking place, even that can be detected and counted, that can be counted by this spectrometer. Okay. Now, if you look at this methane satellite, it is going to cover somewhere around 200 kilometer to 200 kilometer field of view. So, 200 kilometer by 200 kilometer means it is going to cover a very large portion at one go. That is a good thing, and it is going to detect super emitters as well as smaller resources. It is the same thing that I talked about spectrometer right now, that even if micro detailings are needed, even there are very small even if there are very small sources, the emission is taking place, but taking place in very low quantity. Those are your smaller sources. Those will be detected, yes. But there are some sources which are emitting methane in very high quantity. Let us say there is a factory, or let us say you talk about the China which is having the factories hub, and from China how much we are getting. All that will be your super emitter part. All these data will be provided. Okay. Now, if we further see it, we say that this methane sat is using inverse model, wherein the data we are getting is top down as well as bottom up. What they will do is, top down approach, what they will do is, using this satellite, whatever data they can grab from satellite, from top to the down, they are getting all that data. Okay. And there is some data that they are getting from bottom up approach. That means from the units they have at the local level, ground based observing units, from that also they are getting some data. They will integrate both datas and finally they will come up with their real time monitoring data. So overall we can say top down approach, bottom up approach, both are being used over here in this methane sat mission. Now, is it going to be helpful for us? Yes, it is going to be helpful. First of all, it is going to help us in the climate action. See, because if in case the methane gas and its amount in the atmosphere is increasing, that is leading to global warming. If you want to reduce it, you need to reduce the methane amount. So there is a pledge taken by countries called as Global Methane Pledge. It's a voluntary framework taken by United States and European Union. They said that we are going to reduce methane by 30% by the year 2030 as compared to 2020 level. So whatever amount of methane was present in the atmosphere in the year 2020, as compared to that 30% will be reduced. It's a pledge, it's not something legally binding treaty as such. So only countries are expected to voluntarily take some actions for it. Okay? And this was launched at COP26 in 2021. Okay. One thing you need to know, I said that in real time all the data will be published publicly. Now this will have a big pressure or an ethical moral pressure on countries. See, when you are saying that this country is leading to methane emission in this much amount, real time you can see all the data of all the countries, all the places. Now no country can deny it. So there will be a moral pressure built because of this transparency of data. That's a good thing we can say. Okay? So this was all about methane sat. Interesting? Yes. Now the next one. The next article. Yeah, please ask if you have any doubts, or else I'll head towards the next article, that is about asteroids and planetary defense. No doubts? Fine then. Now let's move ahead with the next article. Now this one is related to asteroids. You all must have heard about asteroids. In the geography we anyway read about asteroids. So especially if I have to talk about asteroids, you see some large, some small as well as some large rocky materials. They're just like our planets, but they are relatively smaller than planets, and these rocks are continuously moving or orbiting the sun, right? So there is this asteroid belt over here. Which is present between Mars and Jupiter. It's not like there are these asteroids which are present only between Mars and Jupiter. There are other asteroids also, but here we see them in large quantity. Okay. Now why it is in news? Because recently there was an asteroid called asteroid 2024 PT5. This asteroid recently passed very closely from this Earth. Now we are concerned, if this satellite, if this asteroid hits Earth, it is going to cause enormous damage for the Earth. So there will be a big disaster if in case any asteroid hits. And there is even a claim by some of the scientists that the extinction of dinosaurs could be because of an asteroid hitting the earth. That could be one of the reasons. So, from that we get an idea about how dangerous this scenario could be. Now, when we talk about asteroids, first of all we call them as minor planets. They are just like planets, but they are small. Now, when you compare them with the planets, we get to know one thing, that planets look round, or let us say circular, whereas these asteroids, their shape is not like planets. Reason could be because of gravity. When it comes to the planets like Earth, Jupiter, Mars, we have a very heavy size, and we have got enough gravity to make it spherical, we can say. In case of these asteroids, the gravity is relatively very less, or it is not enough to make them like that, make them like planets. Okay. Now, we can even say that they are rocky remnants from the early solar system. When the solar system was developing, at that time some planets, either they got destroyed or they could not completely form. So, these are those remnants in the form of asteroids, and they are also orbiting Sun, just like Earth, Mars, Jupiter is doing this in an elliptical path. Now, if you see the size of these asteroids, some are very small, some are very large. So, the size is less than 10 meters to hundreds of kilometers. Can you see the range? Less than 10 meters, that is very small, that is, we can say, let us say even smaller than a room's length, and larger ones hundreds of kilometers. Now, can you imagine this size, right? Now, when we talk about these asteroids, because different kinds of asteroids are present, so we try to classify them. One of the classification comes because of their orbit, where they are they orbiting Sun, or where they are exactly located. Considering that aspect, we classify them. So, one is this main asteroid belt. Now, this main asteroid belt is the same one which I have shown you over here. Here you have the Sun, here you have Mars, here you have Jupiter. In between Mars and Jupiter, you have a long chain of so many asteroids, and this is the one which we are saying over here as main asteroid belt. Okay. Most of the asteroids are present in this one only. Okay. Then second one we have, which are called as Trojans. Now, Trojans are very interesting. They are sharing the orbit of other planets. Let us say we have Jupiter. Jupiter is orbiting Sun in this way, and it has got its own orbit. No other planet is disturbing that orbit, but there are some asteroids which are in the same orbit. Obviously, they are located with a substantial distance, or we can say a safe distance from Jupiter, but they are also orbiting Sun in the same orbit. So, same orbit is being shared, that is why we are calling them Trojans. Okay. That is a different category. And third category would be near Earth asteroids. Those asteroids which are coming very close to Earth, which are located very close to Earth, we are classifying them separately. So, for example, around 1400 near Earth asteroids, or we have also called them potentially hazardous asteroids, because they are so close. Now, because of the gravity of the Earth, there is a possibility which is always there that these asteroids can directly hit Earth, and that will be a very disastrous moment for us. Okay? Near Earth asteroids. So, this is one kind of classification. Other classification, which is a bit more technical classification, is by the composition of these asteroids. What is present in these asteroids? What kind of mineral, what kind of a rock? Considering that composition angle, we can categorize them into C type, S type and M type. C type means carbonaceous. You look at all the asteroids, 75% of these asteroids are C type or carbonaceous. And we can say that they are very similar to Sun. If you look at the composition of Sun, don't just talk about this hydrogen and helium, remove the hydrogen and helium part, but if you look at all other composition of the Sun, that is very similar when it comes to these C type asteroids. Okay. Then we have S type, that is silicaceous. So, 17% of the asteroids, they belong to this category. Now, if we see comparatively, this C type 1 is very, very dark. Dark asteroid. Dark asteroid means it is not reflecting sunlight much. Now, when something does not reflect sunlight, it will appear a bit dark to us, right? Some will be emitting or let us say reflecting some sunlight, they will be relatively bright. So, if you compare C type with S type will be relatively bright for us. And if you see the composition, it has iron plus silicates. Then the third category, M type, we call it metallic asteroids. So, the composition, when we talk about it, it is metallic in nature, and the metal would be iron. They are iron rich and they are relatively more bright when we compare it with C type or S type. Okay. So, we understand this classification, right? Classification based on the orbital characteristics or location, these three, and classification based on composition, these three. Okay. Now, when we look at so many asteroids, now it is very difficult to understand which asteroid we are talking about. That is why we need to give a name to them. So, there is a system, because so many asteroids are present. So, we have to give a name. So, we have a system. So, we have International Astronomical Union, and this International Astronomical Union gives name to these asteroids officially. Now, what happens usually when we discover any asteroid, first of all a provisional name is given, but later on names are suggested by different scientists, different people. So, there is a guideline given by this International Astronomical Union. So, they say that this name should be pronounceable, non-commercial and not related to any political or military figure. This is very clear guideline given. And when names are suggested, later on the permanent or final name is given, and this committee, this International Astronomical Union's Committee on Small Body Nomenclature, this committee finally gives the approval for that name, and finally this asteroid gets a final name. So, you see the asteroid about which we are right now talking about, this one is asteroid 2024 PT5. Right. So, this name 2024 PT5, this is the name of this asteroid. Okay. Now, in this article we are not just talking about asteroids, but something called asteroid and its planetary defense technology, which countries are developing or have developed. Planetary defense mechanism. Now, what do we mean by that? I said that we are concerned about asteroids because they may hit us at any point of time. So, what kind of defense mechanism we are having? That defense mechanism is planetary defense mechanism. So, there will be different kind of defense mechanism. For example, one is called asteroid deflection technique. Deflection means you are just trying to push it away. Let us say here we have Earth, and this asteroid which is orbiting and it has come closer. Now, what we will do is we will just push it in such a way that it changes its orbit and it will not come to Earth. Now, this is your asteroid deflection technique. Let us say this is this kinetic impactor, one of that. There are different methods, but one of that is kinetic impactor. What we will do? Let us say this asteroid is coming to Earth. We will send one spacecraft, and the spacecraft will directly go and hit this asteroid. Kinetic impact is there. Because of this kinetic impact or this hitting, now it will change its orbit or its location. Got it? This is called kinetic impactor. The best example of this kind of a technology is your NASA's double asteroid redirection test, which is in short called as DART mission of NASA. DART. So, here they did the same thing, they demonstrated, United States of America or NASA demonstrated that they are capable of this kinetic impactor, doing this kinetic impact on an asteroid using this DART mission. They have shown that. This is one method. Other method could be gravity tractor. Now, what we will do here? We will send one spacecraft very close to that asteroid. Okay. And as asteroid is moving, the spacecraft will also keep on moving with it. For a very long duration this will happen, and a very small gravity which will be generated because of the spacecraft, this will change the direction or this orbit of this asteroid to some extent. Now, this is another way we can do it using gravitational pull. Okay. Third way is using nuclear detonation. So, making use of nuclear technology, we know nuclear technology generates immense energy, it can destroy almost anything, and we can even generate energy enough to push any asteroid. So, you can use this nuclear technology and push the satellite, push the asteroid, or even we can completely destroy this asteroid. So, here use this nuclear technology to completely destroy it and break it into so many parts. So, if you go and do this nuclear detonation at this asteroid, so let us say this is the asteroid, it will be burst and it will be converted into thousands and lakhs of small parts. But this is going to be dangerous for us, because all these small fragments, even those fragments can hit us anytime, and this is going to increase the space debris, right. So, that is dangerous for us. Then apart from that, there are other systems as part of this planetary defense technologies, which are called as early detection and tracking systems. So, for example, we have some ground based telescopes, we have some space based telescopes, some telescopes at ground level, some telescopes in space. What all are doing? They are continuously observing these asteroids or anything that is coming to Earth. First of all, these ground based telescopes, for example, this PAN-STARRS, Panoramic Survey Telescope and Rapid Response System, then ATLAS, Asteroid Terrestrial Impact Last Alert System, all these are systems at the ground level. They will track all these asteroids, and those which are missed by these ground satellites, ground telescopes, others will also observe. So, space based ones, they will also observe. So, combined you get enough data in the form of early warning system that some asteroids are coming, or this asteroid might hit us after these many years, be ready for it. So, these early warning system or early detection systems we have. So, this is what we call as planetary defense system or defense technologies. At the global level, many countries have been working on these technologies. For example, we have International Asteroid Warning Network. Now, this is going to help us with tracking all these asteroids and give us some kind of a early warning. Then we have some missions like DART mission, which I have already discussed from NASA. Then from European Space Agency, they have this HERA mission. Now, through HERA what they are doing is, they are observing the result of this DART mission. So, they are collaborating with NASA and coming up with the results of DART to come up with more details. Then we have United Nations Office for Outer Space Affairs. Now, this is very important because this office is providing a platform through which we can collaborate, and we can collaborate especially in the field of planetary defense. So, they have provided a framework. The name of that framework is Committee on the Peaceful Uses of Outer Space, through which countries can collaborate on this particular problem, because every country is going to face the consequence of an asteroid hitting Earth. That is the reason international collaboration is certainly needed. Okay. So, that is all about this asteroid and planetary defense mechanism. So, let me check if we have any doubts till now. No? Okay. So, I do not see any doubts till now. So I'll just move ahead. If you need a break, take few seconds of break. We'll continue with this. Okay, now we'll move ahead with the next satellite. That's the name of this satellite is LignoSat. This is very interesting, and this is not a big news as such. News as such, as in for the preparation purpose, I am saying. Okay, as far as the technological aspect is concerned, for space technology, this is highly important. Okay, for exam perspective, we just need to know the basic part about this LignoSat. Okay, ligno, the word ligno we use when it comes to wood, right? So we are talking about something called LignoSat. What is this LignoSat? Now this is a satellite that is being launched from Japanese side. Okay, and what Japanese are doing, they are sending this particular satellite to International Space Station using SpaceX Dragon capsule. Now they are sending it to International Space Station, that's fine. What is so special about this LignoSat? That this is world's first wood panel satellite. Normally when we are making any satellite or something, we try to make use of metals. And now what Japanese are saying, instead of metals, we'll make use of wood. How interesting, very interesting. Why they are doing so? Why they are even thinking about making use of wood? Because you see the space environment, there is very extreme kind of temperature when it comes to space, and the temperature keeps on changing. You'll see that within 45 minutes only, the temperature might change from minus 100 degrees Celsius to plus just 45 minutes. This variation is possible in the space. First thing. Now, will wood get affected because of this temperature or not? Because other metals, they might be getting affected. Now, we want to make use of wood because we think that maybe wood will not get affected. Now, you might say, sir, it will be burnt when we are putting it at 100 degrees Celsius temperature. But to burn, you need oxygen. You need oxygen. No such oxygen is present in the space. In the space, you don't have air, you do have just vacuum. So, there is no oxygen. So, it is not going to catch any fire as such. Secondly, there is no water also. So this wood is not going to rot. If there is water, it is going to rot, but there is no water. So Japanese are considering using this wood, that this would be a better material than any other metal when we are making something related to space. And historically also we have made use of wood. Let's say when we were making airplanes, the early airplanes, they made use of wood, or this wood and cork. Both of these are used in the spacecraft, this re-entry protection part. For that, we have already used wood. So this is not something new. But now Japanese want to check, they want to test whether we can really make use of this wood. We can conduct any microgravity experiment in that spacecraft which is made up of wood. All that is being checked, and to check that, they are sending this LignoSat. Okay, now factual part, the developers of this LignoSat are Kyoto University and Sumitomo Forestry. Okay, these two are the developers from Japan. The purpose is to test the durability of wood in the space, its ability to shield semiconductors from radiation. So whatever radiation, whatever energy that is coming from sun, is it going to affect this wood? Because anyway, the satellites which we are sending, the spacecraft which we are sending, it will have some semiconductors in it. Those semiconductors are helping us with all the data, all that communication part, everything that is being done using semiconductors. Now here, protecting these semiconductors is very important. If you can protect it using wood, that's a very good thing. We'll make use of wood. So This mission is checking or testing the durability of wood, whether the wood can stay there in space and protect these semiconductors. It can act as a shield for these semiconductors, whether it is possible or not. That is being checked over here through LignoSat. Clear? Now see the design part. It's a very small kind of satellite, we can say. 10 centimeter into 10 centimeter into 10 centimeter. The length, the breadth and the height. Just 10, 10, 10. So very small one, this much size, we can say, this much size of satellite. Okay, the weight is hardly 900 grams, less than even 1 kilogram. And it is made from magnolia wood. I'll just highlight this part because you need to remember this particular part, that this is made up of magnolia wood. Okay, remember this name. Now one more thing they have done is they have not used any screw or something as such while making this particular satellite. So they've used the traditional Japanese technique of interlocking. So they have done the interlocking, and through interlocking this satellite has been made. So very interesting, we can say. So this is all about your LignoSat. Very easy, very short, right? Now, any doubts? No? So we're going good. Okay, fine. So we're done with LignoSat 2. Now moving ahead. See, we are going to cover the entire part of space technology today. So apart from this, we have this mission SCOT, we have this IRIS to space program, then we have MACE observatory, we have PACE satellite. Then we'll start with the missions of ISRO specifically. So there are 4 or 5 missions which are quite relevant for examination. So we'll talk about SPEDX mission, we'll talk about Trishna mission, then we'll talk about GSAT 20, very very important, I can say. Then we have ExpoSat, good one, and at last we'll deal with NAVIC. Okay, NAVIC is also highly important for examination. So these are the articles that we are going to discuss today, and we'll complete this section or segment of space technology. Okay, now heading towards the next topic or next article, that is mission SCOT. Now when we say mission SCOT, the long form of this SCOT is Space Camera for Object Tracking. Now I don't need to give you any explanation if you can understand this term itself. Space camera, there is a camera which is going to track objects in the space, whatever objects we have in the space. So recently there is a startup called Digantara, an Indian startup. Now this startup has made and launched one satellite, and this we call as world's first commercial SSA satellite. What do we mean by SSA? It's called Space Situational Awareness. It is the world's first commercial, I'm not talking about the government agency satellite, a commercial one made by private sector, and this is made for space situational awareness. What do we mean by this particular term? You see, last time in the last lecture I discussed about space debris problem, that this is going to be a very dangerous problem for us in future also, at present time also this is a big problem. Now when you look at the space debris, there are so many things, so many objects in the space which are moving, and nobody has an idea about how many such objects are actually there. Now here we have one particular satellite specifically to check all these objects, specifically to track all these objects. And when you when you track all these objects, all the objects, I'm not talking about just one spacecraft or satellite, I'm talking about everything that is present there. When you give this data to someone, we say this is what we call as space situational awareness. What is the situation in this space? We will be aware of it using this data, and this will be done using this mission SCOT. Okay, so here they're tracking resident space objects to enhance space safety. What do we mean by resident space objects? I said all the objects. We have some satellites which are active, which are working right now, those will be part of it. Some which are defunct, which are not in working. Okay, we used it, let's say 10 years back, 20 years back. Now these satellites are useless for us. They are just moving in the orbit. Even those will be taken over here. Then spent rocket stages. Whenever we are sending a launch vehicle, each stage completes its fuel, and then it falls back. Some will fall back in on the earth, but some will keep on moving in space. So those spent rocket stages and other space debris, whatever debris, even if there is a screw or anything that is moving in this space, all that, and all this is there in the low earth orbit. See, we are talking about low earth orbit because most of this space debris is present in the low earth orbit. So whatever such thing is there, we call it resident space objects. And the core objective of mission SCOT is to track these resident space objects which are present in low earth orbit. Is this clear? Yes, this is the core part of mission SCOT. Now this is being said that it is way better than the traditional systems because it provides continuous and precise tracking. It is being said that this mission SCOT, this satellite, can even track something which is as small as of 5 centimeters. 5 centimeters, this much only. So such a small thing, if it is moving in the, if it is orbiting or moving in the space, in the lower orbit, that can be tracked by this mission SCOT. Now, traditional systems or other systems which you are using for tracking space debris, they might not be in a position to track such small objects too, but this one can do it. And even this much small thing is dangerous for us because they're moving with speed somewhere around 28,000 kilometers per hour. That's a dangerous thing, right? And here we have some private sector elements like this. Aditya Birla Venture is there, who is backing it. We have SIDBI, who is backing it. So financial part when it comes to, so there is a backing from Aditya Birla Venture and SIDBI. This is the factual part we need to know about mission SCOT. So this is a brief news for us to study, but it's an important news, right? Important news, that's why it's relevant for the examination too. Done? Now the next one. Next one is called as IRIS 2 initiative or IRIS 2 program. IRIS 2 space program. Now what is this IRIS exactly? So you can see the long form. Please read this long form. Infrastructure for resilience, interconnectivity and security by satellites. Okay, just try to read this particular statement. You know these terminologies. There's nothing new about it. Just read and think about it for 5 seconds. So this particular initiative is coming from Europe. European Commission has signed a contract with this Space Rise. Now Space Rise is a group, it's a coalition of some companies which are working in this satellite segment, or they are operating the satellites, or they're making satellites, or whatever. So there is a coalition. That coalition is called as Space Rise. With this, European Commission has made a contract for this IRIS 2 space program. Now, the key goal of this IRIS 2 space program is to connect and link different satellites. So, they want to actually bring in satellite connectivity, that too for high speed communication. So, you must have heard about something called satellite based internet, right? Or satellite based communication, right? So, here we are talking about similar stuff, wherein we are saying different satellites will be connected. A global satellite based internet and secure communication system can be established. So, if you want to communicate something to others, you want that communication to be very secure. Let's say military personnel are using it. So, you want that it should be end to end encrypted from you, this side and that side. Both sides should have end to end encryption. So, all that will be provided with this secure communication provided by IRIS-2 mission. Okay, and satellite based internet also. Now, this will be helpful for government as well as non-government entities. So businesses, citizens, everyone can use this particular infrastructure. Now, how many satellites are being used over here? This is very interesting. The total number of satellites being used over here are 290 in number. So please imagine the numbers. That's why I called it a big project to connect, right? 290 satellites. Out of these 290 satellites, 264 are in low Earth orbit. They're orbiting in low Earth orbit. That means less than 200 kilometers away from the Earth's surface, or at the altitude of maximum this. And 18 in medium Earth orbit. Okay. Now, all these will be connected to each other and they will come up with information. Now, these satellites, they are continuously observing, they are communicating with each other, they are getting the information from the earth. So they will be providing high speed coverage without needing thousands of satellites. The kind of internet or kind of communication we actually need, the high speed one, we might require 1000 plus satellites, but that will be done by just 290 satellites, is what this European Commission is saying, or this mission is specifying us. It is designed specifically for low or no network zones. So there are some areas which are remote areas. You go to Andaman, you go to Ladakh. There are some areas which are very remote areas. We don't have any internet connection. No communication is generally easily possible in those areas. So there also this communication can be established. Internet connectivity can be established using this IRIS to space program. Okay. Now this is technical part. We need to remember. There's no way, no other way. Now, as far as the application part is concerned, I said governments will also use it, businesses will also use it, citizens will also use it. How? For governments, border and maritime surveillance. Now, they need secure communication and they need continuous data. So sometimes border areas, like if you see the border, India's border with Pakistan or Bangladesh, or let's say China, sometimes the borders are porous, sometimes there is mountainous region. It's very difficult to have communication over there. So border surveillance, maritime surveillance, all that will become easier using this IRIS-2 program satellite. Then in case of any disaster, any crisis, there also you can utilize it. For security of critical infrastructure, some infrastructure which are very critical, very important, let's say cyber security infrastructure, we can say. Then defense and military operations. For defense operations, we said we need secure communication, right? So all that will be done. Then commercial or the business's purpose or civilians use, for example, for transport sector, maritime, railway, aviation, automotive, everywhere it will be used. For some smart systems like energy grids, banking, etc. For rural areas, I talked about remote areas, but when it comes to rural areas also, we don't have really good broadband connectivity when it comes to rural areas. Now that will also be provided using this satellite based internet, right? Then we can provide cloud based services and navigation in low connectivity zones, again those remote areas we can say. Okay, so all these are the benefits or applications of IRIS 2 space program. Fine. Now the next one, we're done with iris 2. Now the next article is about an observatory. So it's a telescope, we can say. In simple terms, it's a normal telescope. So the name of this telescope or this place or this unit is Mace Observatory. The name Mace is Major Atmospheric Cherenkov Experiment Observatory. Okay, you can read it once, please. Major Atmospheric Cherenkov Experiment Observatory. Now, recently this observatory is inaugurated in India, specifically Ladakh. In Ladakh, there is a place called Hanle. Okay, so at this place, look at Ladakh. Ladakh is at a higher altitude. Okay, and that's why this observatory becomes important, because most of the observatory we see are located not at such higher altitude. So when it comes to this Ladakh location, this is something unique. This is something unique about this observatory, that it is located at a very high altitude. Okay. Now it has been inaugurated recently by Secretary of Department of Atomic Energy and Chairman of Atomic Energy Commission. That's why it is in news. Now what's so special about this Mace Observatory? First of all, it is going to study gamma rays. Okay, gamma rays, you must have heard about gamma rays, right? When you look at the electromagnetic spectrum, we have visible light, we have X-rays, we have radio waves, etc., infrared and all. Now, one of that is your gamma rays, right? One of that is your gamma. Now, when you look at these gamma rays, the special thing about these gamma rays is they are having the shortest wavelength. Now, this is an important point you need to focus on. Their wavelength is the shortest. So, the energy that you get through gamma rays will be very dangerous. When you look at wavelength, see, normally this is the wavelength you see. When it comes to gamma rays, I am saying their wavelength is less. So there will be something like this. So the amount of energy you are getting is extremely high. Okay. And you see the origin of these gamma rays from neutron stars, from pulsars, from black holes, from supernova, and many more things. Scientists are still studying about these gamma rays, where they are coming from, what's their source, etc., etc. Okay, and in studying these cosmic gamma rays, this Mace Observatory is going to be helpful. Clear? Now, as I said, it is located at higher altitude in Ladakh. So it is located somewhere around 4.3 kilometer above the sea surface level. That is unique, and this makes it world's highest imaging Cherenkov telescope. World's highest, right? 4.3 kilometer above the sea surface. Now here we are using a term called Cherenkov telescope or Cherenkov. Now there is something called Cherenkov radiation. You see, you must have heard about this concept called speed of light, that nothing in the universe can travel faster than speed of light, right? But if you check the same thing in a different medium, when you say the statement that nothing in the universe can travel faster than speed of light, you're talking about space, you're talking about the vacuum. In the vacuum, you're saying that nothing can travel faster than speed of light. But if you take any other medium, let's say I take water, I take water molecules, I take some water molecules, and in that water molecule, if I pass on the light, now here what happens, light slows down a bit. It slows down as compared to vacuum. Here light will travel but relatively slower. Okay, and here it is possible that there are some things which can even travel faster than the light in these water molecules. So let's say there are some charged particles, let's say some electrons and some charged particles which are traveling faster than speed of light in some mediums, in some materials or some mediums. then at that moment we get a special light, let's say a blue colored light. The special light that we get is what we call as Cherenkov radiation. It's a light emitted when charged particles travel faster than speed of light in that particular medium. This happens. Okay. And the task of this maze observatory is to detect that Cherenkov radiation or Cherenkov light, that blue light which is coming, that will be tracked by this maze observatory. Okay. Now, if you see its size, it's somewhere around 21 metric wide. So it's very wide. That's why it's Asia's largest and second largest globally. And who has built this particular maze observatory? We have multiple agencies involved. We have BARC, that is Bhabha Atomic Research Center. We have TIFR, that is Tata Institute of Fundamental Research. We have ECIL, and we have Indian Institute of Astrophysics. So these four agencies are involved in building this maze observatory. Okay, so good. This is all about your maze observatory. Very easy. Okay, very easy and relatively factual, we can say. Let me check if we have any doubts. No? Good. Okay. Now, the next one, space satellite. Now, the space satellite, you should know the long form of space. Plankton, aerosol, cloud, ocean ecosystem satellite. Now, last time in the last lecture, I had discussed about cloud and aerosol part, how cloud and aerosol interaction is leading to some kind of working in the climate change. Sunlight that is coming, that will, some of the sunlight will be transferred back to the space, some will be absorbed because of aerosols. So clouds, aerosols play an important role when it comes to global warming, climate change, etc. Now the space satellite, what it is going to do, it is going to observe cloud as well as aerosol as well as planktons. Now planktons you must have seen when it comes to ocean ecosystem. In the oceans you have this very tiny organisms called as planktons, or you must have heard phytoplanktons also. Okay, now you see the food chain of ocean ecosystem or aquatic ecosystem. In the food chain, the first trophic level is made up of these phytoplanktons. So if phytoplanktons, their numbers increase, things will be different. If their numbers reduced, the entire ecosystem can be collapsed. That's the reason this space satellite is focusing on these planktons also. They're observing it. Okay. Now this one was launched by NASA from Cape Canaveral Space Force Station. What it is doing is it is orbiting in this sun synchronous orbit. Whenever something is in sun synchronous orbit, this satellite will track a particular location on Earth at the same time every single day. So let's say at 12 o'clock it is checking Delhi, it is tracking Delhi. Next day also it will come and track Delhi at 12 o'clock. Okay, so this is how it is going to observe. And what's the objective? To study the interactions among all these things: plankton, aerosol, cloud, all the ocean ecosystem. So oceans, atmosphere, and the climate. Is there any relation? If there is relation, they'll try to understand everything. So you see, we have some technical aspects over here. Ocean, like we have ocean color instrument. So it is going to measure the light, and using this light they are going to know what kind of biological elements are getting affected because of it. So like this, phytoplanktons. Then we have spexon. It is going to study clouds and aerosols, how light is getting scattered because of clouds or because of these aerosols, which we have discussed earlier already. This will be tracked. And we have hyper angular research polarimeter, HARP 2. So it is going to detect polarized light. Now what is polarized light? Normally if you observe, light travels in multiple directions. So if we have a bulb over here, the light will move in different directions. It's not like it will travel in one direction. So this is how normally light is traveling. But when it comes to polarized light, this light is going to travel only in one single direction. Okay, this is called polarized light. So such polarized light is also tracked by this HARP 2, which is a component. Okay, it's a component of this space satellite. Three components are there. Now, how it will be helpful? First of all, it will track these phytoplanktons, right? It will know whether there is algal bloom or not, how it is coming up. So we can manage the ecosystem and we can detect all these harmful algal blooms and we can stop it. Air quality, because it is observing air also, atmosphere also. So air quality, if there are any pollutants as such, we can observe that. And as far as climate change is concerned, overall with these interactions, we'll get the data enough to understand impact of all these on climate change. Okay, this aerosol, clouds, etc., everything. So this space satellite is going to be helpful for us, we can say. Clear? Very short news, we can say this one. Now we are heading towards the new part wherein we'll discuss some special missions by ISRO, or we'll specifically talk about some missions by ISRO which we consider are relevant for exam and which were in news. Obviously that's why we are taking them. Okay, now one of that mission is SpaceX mission. This was in news. Many articles were there in news, many editorials were written on SpaceX, so very important, I can say. Yeah, any doubt please ask, or else I'll just continue on this. No? Okay. So SpaceX mission, if you see the name, SpaceX means space docking experiment. Space docking experiment. There is an experiment carried out by ISRO showing that we are capable of doing docking in the space. What is docking? Let's say you have one satellite and we have other satellite, or let's say two different spacecrafts are there, and you want to connect them, you want to join them. Why you want to join? Reason could be anything. Let's say in this spacecraft you have some people, some astronauts, and their spacecraft might not be working properly, so you want to connect this different one to this one and get all these astronauts transferred to this second spacecraft. Okay, you want to do this. Maybe this one spacecraft, its fuel is completely exhausted, so it needs more fuel. So we want to do the refueling. For that also you want to connect it with different spacecraft, right? Now in this space, connecting them is very difficult because all these spacecrafts, they are moving with the speed which we can't even imagine, right? And it's not like the speed of all the spacecrafts is same. One might be moving with, let's say, 25,000 kilometer per hour speed, something might be going with 30,000 kilometer per hour speed. So connecting two different objects which are moving with different speeds, that is also very complicated stuff. Okay, so when you do this connection, that's called docking. Similar to what we hear about docking in when it comes to our ports, that let's say a ship is coming, so there's a dockyard. So similarly here we're talking about docking, connecting two separate spacecraft in orbit to form one operational unit. Okay, now here we need one spacecraft which is called as chaser and other one which is called as target. Chaser is going to 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 connect with this target. Okay, and it requires alignment, control, and very rigid connection. And this is a tough thing, and ISRO has said that we have successfully demonstrated our capability of docking in the space using this SpaceX mission. We have done this for the first time. Okay, now see, what was the objective? Demonstrate autonomous space docking technology, which we have done. The chaser that we have is SDX-01, target is SDX-02. The orbit is 470 kilometer in the low Earth orbit, and the docking was done at the speed of 28,000 kilometer per hour. Now this experiment, when we have done this, when we have demonstrated this technology, the world has understood that we can do this. And for us also it is very important because now we are planning Gaganyaan mission where we are sending astronauts there is a possibility that we might need to do this docking in case of any problem or something. So for human space flight, it is important. For any future experiments or future missions like interplanetary missions from one planet to you want to go to other planet, there you might need some kind of docking which is needed. Then we are planning Bharatiya Antariksha Station, just like we have International Space Station. India is saying we are going to build our own space station. Now, if you're building a space station, so it's a spacecraft on its own. If you want to send other astronauts there, you have to dock this new spacecraft to this space station. So docking capability is certainly needed. Okay. So this is all about your SpaceX or space docking experiment mission. Now some technical aspects, the same thing but in technical words if I have to say it. So one is autonomous rendezvous docking. So fully automatic navigation and secure docking. Whatever docking is being done, it is not like from some computers at here and with the scientists they are doing it. No, it's a completely autonomous system. There are sensors, there are machineries, there are systems of robots which are autonomously doing this all docking thing. They are calculating the the distance, they are calculating the speed, everything, and they're doing it. So this is very interesting about this mission. Then formation flying means you need two different spacecrafts and they have to come up in a precise manner. Speeds are different, so this is called formation flying. So speed will have to be maneuvered. Then remote operations. So one spacecraft manages attitude control system. Attitude means the orientation or the direction. One satellite might be moving in one direction, so that direction has to be controlled. And robotic technologies, because we said that it is being done autonomously, so robotic arms, robotic part is very important over here. Okay, this is all about your SpaceX. Very important, I would say. Please remember SpaceX. Done. Now next is called as Trishna mission. Trishna, very interesting name. Trishna. Now what is this Trishna all about? The name Trishna means thermal infrared imaging satellite for high resolution natural resource assessment. In short, it is called Trishna. So see, we're talking about thermal infrared imaging. Okay, thermal infrared imaging. Now recently, the details regarding this Trishna mission are published by ISRO on World Environment Day. Now here what we are doing is we are trying to observe all the natural resources on Earth using this infrared imaging, thermal infrared imaging capabilities. Okay. Now this mission, it is going to this satellite is going to orbit. It will be a sun synchronous orbit, 761 kilometer altitude, and at 12:30 p.m. it is going to cross equator. This is the factual part. Now this one will have lifespan of 5 years. Now important thing is what it is going to help us with. First, see, it has got this thermal infrared payload. Now this one is given to us by France. So it's not like only India is involved, here France is also involved. France agency called CNES. So they're capturing the thermal images of Earth. Using those thermal images means different temperatures, at different temperature scales they will take images. So they will understand the heat stress in crops. In the agriculture, if you see heat stress, they'll understand. In the urban areas, what kind of temperature is there? This heat zone, which heat zone is there? Urban heat island effect, everything will be understood. From water side also, they'll understand everything through these thermal image. Then what India has helped us with, this VNIR's SWIR payload. So this satellite includes some part which is called as visible and near infrared and short wave infrared. This is going to capture the vegetation part, the soil part, the plant productivity part, water pollution part, all this will be identified. So overall, if I have to say how this mission is going to be helpful for us, so it's going to monitor energy and water budget. You see how much energy is coming from sun, how much is going out, that's your energy budget. right? If you look at water, how much water is getting evaporated, how much is coming in the form of rainfall and all that is your water budget part. This will be considered, this will be looked at using thermal imaging. High resolution observation of water quality also. So if water contains some kind of contaminants, some pollutants, that will also be observed. Urban heat island effect will be assessed. You see, if you compare rural areas with that of urban areas, you will find that urban areas, there you will find more heat, and this is your urban heat island effect which is being observed. Then thermal anomalies and geothermal resources. So the pattern of this heat is different everywhere. That pattern will be observed. Somewhere we have geothermal resources, those will be observed. Then we will monitor the snow melting, glacier melting, etc. and atmospheric part also. In the atmosphere also, what kind of gases are there, how much temperature is there, all this part. Okay, this will be very helpful for us. So a decent mission, Trishna mission from ISRO as well as the France agency called CNES. Okay, important mission, yes, important mission. Now next is GSAT. Then after GSAT we'll study EXPOSAT, and the last will be NAVIC. Only 3 articles are remaining, so show some patience, I would say. Okay, GSAT 20. Now this is one of the most important articles, I'll say. GSAT. Whenever we are sending any satellite, we give some kind of a name. Okay. Now here GSAT 20, it's also named as GSAT N2 satellite. We call it India's most advanced communication satellite. Most advanced communication satellite. Now this is very important. India has sent many satellites which we call as communication satellites, and communication satellites are sent to a longer range, or we can say the high altitude, not the low Earth orbit as such. Send it to a high altitude, and they are helping us with communication technology. Now the most advanced one till now is this GSAT 20. Okay. Now to launch this, obviously ISRO made this, but to launch this they have made use of SpaceX Falcon 9 rocket, and they've launched it from Cape Canaveral in Florida. Now you may say, sir, why are we using this SpaceX Falcon 9 rocket and not India's own LVM-3, our Bahubali launch vehicle? So there is a reason. Reason is India's capability when it comes to sending large or heavy communication satellites. So you see, ISRO's capability, ISRO's capability when it comes to launch vehicle Mark 3, in low Earth orbit we can send up till 8 tons. In geostationary transfer orbit we can send at max 4 tons. And when we are sending a communication satellite, obviously we are looking towards this geostationary transfer orbit. So our maximum capability is 4 tons, not beyond that. So if we are sending any package which is having weight higher or more than this 4 ton, then we have to go for other countries. So we were, to some extent, we were dependent on European Space Agency. They have got this Ariane 5 rocket, and its capability is somewhere around 10 tons. So most of the times we made use of Ariane 5, Ariane 5 launch vehicle from European Space Agency. But recently this Ariane 5 also got expired, or its operation has completed, it has got retired, we can say. And Ariane 6, it was still in developmental stage. That's the reason we reached out to SpaceX from USA, and SpaceX has got this Falcon 9 Falcon Heavy rocket, and you see its capability, it can send up to 27 tons of payload. That's the reason we have sent it using this Falcon Heavy rocket. Okay. So this has been launched. The deal which was made, it was brokered by New Space India Limited, that is NSIL. So earlier I had talked about NSIL, that it's a commercial wing or commercial organ of ISRO. It has facilitated this particular deal. Now if I talk about this GSAT 20 specifically, what it is going to provide us, communication. What communication? We're talking about the internet part specifically. So it is going to provide us with very high throughput. Throughput is, you can say, the amount of data that is getting transferred at one point of time. So downloading, uploading, all that part, when we say that is your throughput using a bandwidth specifically. So 48 Gbps data rate can be provided using this. So very high speed. Then it's using Ka band technology. Now Ka band operates in this range 27 to 40 gigahertz, and this is a very high frequency range. So if you're using high frequency range, you can say that this satellite can handle more data at the same time. So this will be very helpful in streaming, in the internet, also in broadband services everywhere. Specifically in streaming, this will be very helpful. Okay. Then it will have a wide coverage. Now in this satellite, we have 32 beams which are being used for transmitting those signals. So all these beams are covering wide area. So as far as India is concerned, almost every part of India is covered over here. Specifically, when it comes to these remote areas like Andaman Nicobar, Jammu Kashmir, Lakshadweep, all these are also covered by GSAT 20. Okay, and this is going to be very helpful considering the digital connectivity part. And we are in competition with other countries, because when it comes to satellite based internet, many private companies are competing right now from world level. So we have this OneWave, we have this Starlink project. All these are competing for providing global satellite based internet, and here ISRO is sending its own GSAT 20 to provide the same. So we are in competition, you can see. Okay, so this was all about GSAT 20. Very easy again. Now only last two articles are remaining. One is called as Exposat. Okay, now if you remember, earlier I discussed about one satellite wherein what we were observing was gamma rays. Now similar to gamma rays, now in this Exposat we are going to observe X-rays. Now this is ISRO satellite, India's first X-ray polarimetry mission. So X-ray polarimeter satellite, that's the long form of Exposat. What it will observe is polarization of intense X-ray sources. I've discussed the polarization of light already, right? That in single direction this light is moving, that is your polarized light. So how it is moving, why it is moving, from where it is coming, everything about only X-ray, not any other electromagnetic spectrum, only about X-ray. This will be observed by this Exposat. And who made this? Obviously ISRO in collaboration with Raman Research Institute from Karnataka. Now when we do all this stuff, when we study about X-rays, we get to know about many things, like we get to know about black holes, neutron stars, supernova, many other energetic cosmic events that are happening in the universe. We'll get to know about them using this Exposat. Okay, some details, technical details you need to remember. This is sent in low earth orbit. It's a non-sun synchronous, so it's not like every place at same time it is going to come and check. No, nothing will happen like that. Altitude 650 kilometers and mission life is 5 years only. Okay, this was all about Exposat. Now the last one, that is Navik mission, very important mission. Navik. So for the first time, Indian designed microchips will support Navik navigation service. This is the news, that's why we are reading it. Okay, what is Navik? If you see the long form, it's Indian Regional Navigation Satellite System. That's the real name, that is IRNSS, which I showed you in the previous year question. That's the name, the real name. The other name which is given over here is Navik, showing the navigation part involved over here. Who made this? ISRO has made this. It was approved in 2006 and it got delayed to some extent, and in 2016, I guess 2018, it has become operational. What is happening? It's a navigation satellite. So just like GPS, just like GLONASS of Russia or Baidu of China, we have our own system called IRNSS, which I discussed in the first article today. Okay, that's your Navik. Now here, if you look at the IRNSS system, it's not like there's only one satellite which is sent and that is observing the Earth. No, there are total 8 satellites, out of which 7 are operational. Now out of these 7 satellites, 3 are sent in geostationary orbit. They are stationary, they are not moving. Whereas geosynchronous orbit, there are total 4. Okay, 3 in geostationary, 4 in geosynchronous. Please, this fact is important. If you see in the previous year question also, they have asked about this particular. Okay, its altitude is 36,000 kilometers above the earth. Again, it's navigation satellites, just like communication satellites. These navigation satellites, they can be at different altitudes or very heavy higher altitudes. Okay, now the services it is offering us, first thing, standard positioning service, just like your global positioning service. So for all the users, it is going to provide us with that mapping part, location part, all that part, and it is having a very high accuracy. So 5 to 10 meter in India and 20 meter in Indian Ocean. So something which is of a scale 5 to 10 meter, even that will be shown with accuracy. Okay, then there is something called restricted service. So for our military or some segments, we have kept some restricted service. So it is encrypted and it has very high precision. Accuracy is 1 to 5 meters. That means you can even know micro things using this restricted service. Okay, and the frequency band it is using is L5 and S band. This is the technical aspect you need to remember. Currently, this IRNSS or NAVIC is being used by almost all the citizens. We just don't know about it. Okay, so for public vehicle tracking, this is being used. For any emergency service, let's say for fishermen, some kind of alert has to be provided. For that, they're using it. Disaster warning and response, for that also we're using this NAVIC. Okay, NAVIC or IRNSS, both are the same thing, nothing different. Clear? Now, if you have any doubts, please ask. I'll wait for 1 or 2 minutes and then we will wrap up this session. We have completed the space technology part completely. Okay, so next, in the next lecture, we'll start with the next theme to cover up our science and technology articles. Okay, so please ask if you have any doubts. I'll wait for 1 more minute. See, with this lecture, as far as space technology is concerned, every important mission, every important article we have tried to cover, and you should focus on the most important ones. All those most important ones like the SpaceX, this GSAT 20 which I said, even this NAVIC which I said. You have to understand the relevance that these are more important. So while revising, revise these articles again and again. Those who want to revise it again, all these PPTs, even the compilation material, all this content will be provided to you free of cost on the Narayani's application. So you can download Narayani's application. There in the free material section, you will find this PPT, all those notes, everything that you need for preparing. And this you don't need to even search. In the description box, you will get the link. You can directly click on the link to download this Narayani's application. Okay, so this you can do. I'll wait for a few more seconds to check your doubts, or else after that we'll wrap up the session. Okay, fine. So it seems you have no doubts. So with this, I wrap up this session for today. We'll meet in the next session tomorrow at the same time, that is 12 p.m. We'll cover with the next theme. Okay, few more themes are important. We are going to cover them. Some topics will be there which are miscellaneous. Okay, we can't categorize them in particular themes as such. So those miscellaneous topics also, that part also we'll cover in these lectures. Okay, so I guess only 2 3 more lectures are needed to cover up science and technology, and we'll do that. Okay, so